Everyone, August 15th. Alright, I tried to set up the work on the React Native scroll indicator again, but man, I spent the entire afternoon just to get it to work. There's so many things have changed. I think last time I worked on a code base was 2 years ago, almost 2 years ago. A lot of things have changed. It took a long time, a lot of efforts a lot of hacks to get it back into a shape that I can start working on it. And also need to invest in learning Tmux with NeoVim. I think it's very necessary, extremely necessary to understand how Tmux work with it. I think I need to do the Tmux thing because right now I'm just switching between two terminal sessions, which is not the ideal, because what I like is to have one screen with at least a couple. Right? The way I like to do it is I have on the left hand side is the code where I code, and the right hand side is a pane, right? We can consider that as a pane that works exclusively on the terminal side of the thing, so that I can do two at the same time. Now I know that NeoVim can do this. It can split into two screens, but I used it before. It was quirky. I don't like it. I don't like the experience. So I'm gonna try Tmux. And I used Tmux before for a separate project, but I never really tried the Tmux with NeoVim option. And I watched a video, it looks pretty nice, and I need to dig into it tomorrow. But anyway, so that's about that. And then let's take a look at the problem today. We have maximum distance in arrays. Maximum distance in arrays. You're given m arrays. Each is sorted ascending. You can pick up two integers from two different arrays and calculate the distance. Return the maximum distance. So I can have two integers from two arrays. So the first thing in my mind is we need to find the smallest. Oh, hold a second. Two integers from two different arrays, which means I cannot pick two from the same array, right? And so basically we need to find the smallest value among all the arrays and the biggest value among all the arrays, and hope that they are in two different arrays. And if they're the same, then we have to find okay, how many do we have? 10 to the 5th. That's what we have. 10 to the 5th. All right. So in the first example, the smallest is 1 among everybody. The biggest is 5 among everybody, and they belong to two different. So that was good. Now, can we just, because everybody is sorted, right? Can we take all the smallest out for all of them? We put it into a list. We sorted it. Then I know, and of course we have to do both the value and their indices. Okay, so we have that. We have from a small to large. We know that, and then we pick the biggest value out. Also put them in, and then we will sort it as well. And we can sort them, let's say descending. Okay, then we check the front I mean, it doesn't really matter, right? So we check the smallest, right? The smallest value among all the arrays and the biggest value among all the arrays. If they belong to two different arrays, then we're good to go, right? We're good to go. If they belong to the same, now that is going to be interesting. If they belong to the same, then we do a cross, right? So the if the smallest one and the biggest one belong to the same array, then I check the second, let's say the second biggest one and third biggest one. So basically, okay, it'll be like this. I fix the smallest value and I check the biggest value from the largest, right? So we just move one by one until we find a big value that's in a different array. So we calculate one result, or we fix the biggest value and the smallest value we try to find the smallest value that's not in the same, and now we find that. Okay, will that give us the correct answer? Basically, we're saying we always use either the smallest value or the biggest value. Okay, so will it be possible that a separate pair give us a bigger one, which means it's neither the smallest nor the biggest? Think about this. If we say there is a pair, okay, which is neither the smallest nor so my current argument is there got to be, right? There got to be one of the result must be the smallest or the biggest, right? But the argument is we can find a pair that is neither the smallest nor the biggest and produce the best, okay? So let's say we have that ready. Now the question is why we cannot use a bigger one. Well, the reason could be, the bigger one maybe they belong to the same, right? Maybe they belong to the same. So we know that the current one, they do not belong to the same, right? Okay, so we have a pair that do not belong to the same, and we say, okay, why cannot we use a bigger value? Then we can say, okay, the bigger value, they belong to the same, so that's why I cannot use it. Then the question is, why can I use because the bigger value and this belong to the same, right? Then why can I use a smaller one, right? And the smaller one belong to the same. So this is equal to this, and this is equal to this. So this, I think I have a solution, and we're gonna try this. I think I can prove, right? We can prove that the result must include at least one biggest or one smallest. So all we need to do now is we need to create two list of int, okay, maxes, all right, and a list of int mins. All right, so max and mins. Okay, new array list. All right, so what we're gonna do is for list of integer a array of arrays, we can say maxes dot add new int is gonna be, oh, that's not right, I0 I smaller than arrays dot size I plus plus. Oopsie doozy. List integer array equal to arrays dot get I. Okay, so here gonna be array max, so should be array dot length, dot size -1, that's the max, and then what? Then index. Okay, and then we're gonna do almost the same for the min. Dot get This is going to be min. This is going to be 0. Okay, and then we can say maxes.sort AB. Actually, it doesn't really matter. We can just go right to left. That doesn't really matter. So max.sort, min.sort. Oh, I think we have to put, that's okay. Alright, we have to put A, B. Integer.compare. Let's say A0, B0. How about we just sort it in reverse order? Maybe it will be easier for us to handle this. And this is gonna be AB. Integer.compare A0 and B0. Okay. Alright, so now we sort them, and then we're gonna say we'll have int res equal to 0. Right? And then we're gonna go fix min and go through max. So min we have fixed, right? And we'll say a while for int I equal to 0, I smaller than maxes dot size I plus plus, right? And because all I want is to find someone that it's yeah, mine was let's do this way. I equal to 0 and say while maxes dot get I 1 is equal to mins dot get 0 1. If they're the same, then I plus plus. Okay, and we find the first one that's not the same, then we can say res is equal to probably also need to say I is smaller than maxes dot get, not dot size. Well, definitely it will be, right? So we're gonna say res shall equal to maxes dot get I 0 minus oh wait, hold a second. My biggest, yeah, it should work, right? Minus mins dot get 0 0 0, right? Because the max is sorting inverse, so we pick the first one. If it's equal, if it's not equal, now I becomes 0, okay? And then fix max, go through min. In fact, let's make this one math.maximum res and this. Okay, and we reset I equal to 0 while I smaller than mins.size and mins.get I1 is equal to max.get 0 1 I plus plus, and then res we can just return math.maximum res and maxes.get I 0 0 0 minus mins.get I 0. Okay, let's take a look. Now I run through this. Maxes. Looks about right. So I'm going to 624. We can prove by way of, and we can prove that the answer must involve at least the min, right? The min of all arrays, or the max of all arrays. Now, if the min and max of all arrays do not belong to the same, right? Do not belong to the same. And actually, this is not what I want to say. Right? Suppose we can find a pair, right? That include neither, I spelled it wrong, neither the min nor the max, right? And yield the max distance. Then we can always use the actual max, right? The actual max to replace the current bigger value to produce a bigger distance. Now, if the actual max is in the same array as the current smaller value, then we can use the actual mean, right? We can use the actual mean. The actual mean, if the actual mean, right? If the actual mean is in the same array as the actual max and current smaller value, then it can pair with the current bigger value to yield a larger distance. If the actual min is not in the same array as the actual max, then we have the actual min and actual max forming the biggest distance. Either way, we can show that at least one of the actual min or actual max must be in the array, in the max distance pair. Okay, I think this sounds logical. Run it one more time and let's take a look. Okay, it's correct, but good lord, it's slow. I think I know why it's slow. I know why. You don't need to do it this way. Okay, so basically what I'm saying is we can do int max equals new int, or we can do n equal to arrays.size, right? And this is going to be n, this is going to be 2. So we don't do this. We get that. And we say maxes I shall equal to looks good. And here we can do the same thing. Okay. All right, so I think this should be arrays.sort. Maxes. Oh, oopsie doozy. Okay, I'm not sure if we can do it this way. Oh, we can. Surprise. All right, so mins. Okay, looking good. All right, so this is going to be n. Oh Lord, this is gonna be I, right, equal to mins. This is gonna be 0. Okay, here, same thing. And this shop is I. Okay, so we make it, hopefully, this is faster. Okay, let's see if it's faster. No, it's not. All right. That is not how I imagine it to be. So now the question is, how can we make it faster? Which part is slow? Well, the part that's slow may be here, because we have to go through every single one. If they're all the same, now it take a while. But no, it shouldn't, because each one we're only collecting one value. So this should only take like 2. Then it should be good. Unless there is a better solution. Maybe we sort the arrays. Huh. Yeah, maybe we sort the arrays. If you sort the arrays from small to large on the front, okay, and we have the smallest, right? And we just need to go find the biggest. Oh, we have the biggest, then we just need to find the smallest. Yeah, if we sort from small to large, we have the smallest, right? And then we need to find the biggest among them. Huh. Then you have to go through them one by one. But here you go through them one by one as well. And you have to sort them twice. Now I'm saying you sort once, you go there, and you go the biggest. Yeah, you go through the whole thing, and you sort it again. So what's the difference in the runtime? Okay, we can find the biggest, sorted it, smallest, if we fit, perfect. Didn't fit, then we need to know the second biggest. What are good solutions for this? Why am I so slow on this? Which part? All right, let's check. Min max. Okay, we got a max and min. Go through everybody. So we keep updating the min and the max. And at each one, we say in the current min and a current max. So at the beginning we have a min max, and at each one, I think what it's saying is as we go through, we try to pick the current max, the current min. So the current, so for each one I have a min max. Each one has a min max. We say up until the current one, but not including the current one, what's the min? What's the overall min? What's the overall max? And we just say if I need to compare with the current min, I will use the overall max so far to compare with this and see if it's good. And I will use the overall min to with the current max to see if it's good. But we're only comparing the first. How about the remainder? What if we have something, if this one is the min, if the current one is the min, okay? And the previous we have some max. Well, if the current one is min, it will be taken up, so it will work for a later one. Okay, that makes sense. Yeah, so if it's the previous max with the current min, then it will work. If the max happens later on, it will also work because the current min will be picked up by the min. So it will be the same for the max. Wow, this is actually pretty smart. So which means you don't have to sort. Okay, there's no need to sort. Well, that was actually pretty bad. Right, we sort this thing. This solution is from the top post. it does not sort. It simply, right, goes through all the arrays and keep track of the overall min and max so far. Then we use the overalls to and the current min max to generate, right, to produce the potential max distance. The proof for this solution is that the max distance will be generated, right, by some min or max value among the arrays, right? Let's say let's just say min, right, by some min value the arrays. Now if the corresponding max value occurs before the min is encountered, right, we can find such max, right, we can find such max as we iterate through arrays. If the corresponding max value occurs after the min is encountered, and then since the min will be captured by the overall min, we can still unite still apply the min to the corresponding max. Very, very brilliant solution. Min shall equal to arrays dot get 0 dot get 0. Max is arrays get 0 get arrays dot get 0 dot size minus 1. Int I 1 I smaller than arrays dot size plus int current min dot get 0 no get I 0 int current max I arrays get size. Okay, rest shall equal to math dot maximum rest. We can say max minus current min. Might get to, let's just do ABS. Min minus current max. Okay. Once we do, we update min. Oh, much faster because it is ON. Lord. 7 milliseconds. Okay, that will be it. All right, so tomorrow I have to, try Tmux.